Okay, so this is day 3, graphing sine, cosine, and tangent sine and cosine without phase shifts. Okay? So, again, one of the things that I always encourage you to do is we're going to be graphing this function, but always writing the parent function equation so that you can compare which transformation is which. So this is the sine function with all of its transformations, so we can determine what exactly these numbers are telling us. Okay, so let's look at k. K is our vertical shift. Okay, and since that's positive 3, we've gone up 3. That's also telling me that my center line is now at positive 3. So we've shifted our sign up 3. This is A. So that is my new amplitude. Originally amplitude is 1. Now it's 1/2, which means this is a vertical compression. So our maximums and minimums are going to be 1/2 away from our center line. This is B. That is what we're going to use to find our change in period. That represents our horizontal stretch of compression. So we use the equation period equals 2 pi over B, because 2 pi is our original period. And since B here is 3, we get 2 pi over 3, which means our period is 2 pi over 3. And again, this is a horizontal compression because it now is smaller. Okay? Now, we're going to start with well, actually we should always start with our horizontal stretch of compression. Okay, so we're going to start with this change in period first. Okay, but before we can do that, we need to draw our parent function. So we're dealing with sine. Sine, the 5 key points of the parent function. And then this is 1 period, the original one of sine. So without any transformations, that's 1 period from 0 to 2 pi of sine. Okay? Now, we're going to do our horizontal compression first. We're going to change our period. So which means my new wave still starts at 0, but is only 2 pi over 3 long. Okay? So it's been horizontally compressed. Now, just like our unit circle, this is pi over 2. Okay? These marks right here represent pi over 6. This one is pi over 3, pi over 2. This one is 2 pi over 3, and this is 5 pi over 6. These are the 30s and 60s from each quadrant, okay, because the pi over 2 was divided up into 3 pieces, okay, just like what we did at the beginning. Which means this is where our new sine wave ends. Okay? And if you think about it in terms of what we did at the beginning of the year with taking all of my x values and dividing them in 3, that means this 0 that was at pi is now at pi over 3. Or, like I told you guys yesterday in the practice problems, think of it as middles, midpoints. In our original equation, our original sine, it begins and ends here on a 0, but in the middle is also there is a 0. So if it begins at 0 and ends at 2 pi over 3, right in the middle, that's where other 0 is. And then between our first two, that's where our maximum is. And the middle of the second two, that's where our minimum is. And I'll get rid of these values so that you can actually see the points. Okay. So here is our horizontally compressed sine wave. Okay. Next, let's do our change in amplitude. So order of operations, all the multiplications. So see how this 3, it's 3 times x, and this is 1/2 times sine. So just like order of operations, I'm going to do both of my multiplications first before I do my additions. Okay? So the second part is now I have to change my amplitude, which means my zeros stay the same, but now my maximums and minimums have been vertically compressed by a factor of 2. The amplitude's only 1/2, so it only reaches to here and here. Yep. So there you go. There's that part. So 2 transformations down. The green one is this 1/2. The blue one is this. Then our last one, we need to shift it up 3 because we were just talking about it. Our center line is here at 3. Okay? The original center line was at 0. So we have to shift everything up 3. So this goes 1, 2, 3, up 3. 1, 2, 3, up 3. Up 3. 1, 2, 3, up 3. Up 3. And this is our final transformation. Okay. And again, double check. Am I on my center line? Yes. My amplitude is 1/2, which represents how far from my center line my function will be seen. So 1/2 up and 1/2 down. Is that where my maximums and minimums are? Yep. It hasn't been moved left or right, and it's been compressed to a length of 2 pi over 3. So everything works out. The other way is to pick a point. So for instance, if I pick f, and I'll use pi over 2. So I'm going to plug in pi over 2 into my function and see what happens. 3 times pi over 2. Okay? So if I plug in pi over 2, so this is sine of 3 pi over 2, because 3 times pi over 2 is 3 pi over 2. What is sine at 3 pi over 2? It's -1. So that means we're taking 1/2 times -1. So this is 3 minus 1/2, which is 2.5, 2.5. So if I go over here to pi over 2, 1, 2, 2.5. So this is point pi over 2, 2.5. And it checks out. We're in the right place.